on this computer? Yep. All right, so I'm recording. Hopefully now I'm recording on this computer. So welcome. We're doing day one, day one of loan calculations and regressions. All right, I already read the learning targets. I already talked about the vocabulary, and I'm recording now. So we're going to get started with how can you calculate and model loan computations. So before taking out a loan, you'll need a complete picture about what your payment responsibilities will be over the life of the loan. What you may not realize is that part of the monthly payment decreases your principal, and then part of the monthly payment is the finance charge or interest. In a savings account, if you have money in a savings account at a bank, the interest is going to be the amount of money that you get from the bank as compensation for keeping your money there. When you put your money in a savings account, it's like you're lending money to the bank. The bank then goes and lends that money out to other people, and then they give you a little tiny interest rate that basically covers the inflation of the money you got in there. You're not making any money on a savings account interest rate. Sometimes less than inflation, which just makes me sad. And then, but for loans, the interest rate is going to be the amount of money that you have to give the bank as a fee for using their money. So interest rate can be money that you're receiving if you're lending out the money, but interest is usually the money you're paying because you're borrowing money. There are many monthly payment calculators available on the internet that can give you a summary of the loan balance over the lifetime of the loan and on a monthly or yearly basis. We'll be looking at those in this lesson. Eventually on one of these days. So I have here an amortization table, which I'm about to show you. So we're going to look at the summary statement of a loan calculator for a $100,000 loan with an APR of 7.5%. So here's our loan amount, $100,000. Here's our interest rate, 7.5%. And it has a term for a period of 15 years. That's our term, 15 years. The loan was taken out in January 2010. And what I want you to notice is that the interest you pay is more than half the amount borrowed. So let's see, look, our first monthly payment, our monthly payment is $927.01. So every month you've got to pay $927.01 on this $100,000 loan. And then of that $927.01, $302.01 goes to paying off your principal. Whereas the interest, it goes to $625. So that first payment, the bank makes a cool $625. That goes into their profit. And principal, your loan only decreases by $302.01 for that first payment. So you'd think like, oh, I paid $927. Now I owe $927 less. That's not the way it works, right? Because loans are amortized, or there's an amortization of the loan where you end up paying the interest up front. The bank wants their interest up front. They want to make sure they're making their profit right away, and that what you owe on the loan goes down kind of slowly over the course of that loan. So we'll get a better idea of how our monthly payment is allocated by looking at the payment schedule for the first year of the loan. So as the months pass, the principal that is paid off by our monthly payment of $927.01, it increases as the interest amount decreases. So let's look at over the course of a year here. In January, $300 goes towards the principal, decreasing how much we owe. $625 goes towards the bank for interest. Go down to the very end of the year in December. Now it's $323.44 that is going towards paying off the principal. So I'm paying more off my principal each month. And then $603.58 goes to the bank for interest. So they're getting less interest as the months go by. Eventually, there's going to be a midpoint in here where the interest and principal paid off is the same. And then towards the end of the loan, these numbers are going to be reversed. Towards the end of the loan, you'll be paying more in the principal than you're paying in interest. Mr. Cranbill wants to add on to that. What do you got, sir?
You nailed it.
Okay.
What I wanted to add on to that was what he's inferring about, like the 15 years. I just lowered my my mortgage by 15 years, or 7 or 8 years rather, from a 30-year mortgage to a 15-year mortgage. He's nice. Right. When you drop it by years, your equity will go up, your principal balance should go down. I mean, they might readjust it, but that's why people go from a 30-year mortgage, which if you did the calculations, Desmond, Javier, and Cayman, you would be paying double your house value. So yes. A 30-year mortgage, take $120,000 house, you'll pay $240,000. If you do a 15-year mortgage, you could shave about 80,000 to 120,000 off the whole price of the house. So that's why
Yeah.
people their mortgage when the rate goes down, and
Yeah.
they tell you to adjust the rate. If it's 1 whole percent, it's significant amount. So that's what my mortgage dropped from like 3 point something to like a 2.5%. So when you do that, you save thousands and thousands of dollars. But it
Yes.
you guys to interpret this, and this is really important for you in the future. Okay.
Thank you, sir. All right. So the first example, actually, this is going to be pretty comfortable for you because we've already kind of been doing this, right? Example one is how to determine the total interest on a 5-year, $10,000 loan at 6% APR. Well, fortunately, we've already been asking you about what the total finance charges are. So this is kind of like review. So we're just going to get solid. Desmond, did you freak out about the monthly payment formula? Did you remember what that looked like again? I had Desmond saw the monthly payment formula and he said, "Holy moly, what the heck is that?" That's that crazy formula that we're going to use. Well, that we can use to find the monthly payment. So
Well, wait, I want to try to. I want to try to do it. I want to try
you
to
want to
do
try
it.
to do it? All right, all right. Well, let's talk about this one and we'll do the next one. All right, because we'll have one set up for you. So the situation is determine the total interest owed on a 5-year, $10,000 loan at 6% APR. So remember, P is the principal. That's where the $10,000 goes in. R is the rate expressed as a decimal. So 6% becomes 0.06, right? Every time you see R, you got to put 0.06 in the formula, just like it is in these 3 places. R shows up 3 times in this equation. And then this 5 years shows up as T. So if we put 5 in for T, so we do 12 times, it's raising to this expression to the power of 12 times 5. What it is, it's saying 5 years, 12 months per year. It's how many monthly payments are going to be made. 5 times 12 is 60. So there's going to be 60 monthly payments. That shows up twice. So we have this expression here raised to 12 times 5, and this expression right here in parentheses raised to 12 times 5 power. Okay, so that's how this is going to be. We're going to run this thing, and so when they just plugged in all the numbers. They put it in their calculator. Calculator says the monthly payment is $193.33. I will remind you that you can press apps right on your calculator, which there's finance apps you have. There's the TVM solver. If you wanted to solve this a little easier, you could say, okay, N is the number of monthly payments. So I have 5 times 12, that should be 60 monthly payments. My interest rate is 6% per year, so 6%. My PV is my present value. That's the amount of the loan. So that's 10,000. Again, this is if you didn't want to use the monthly payment formula. And then we're going to solve for this. So you got to press alpha, enter, right? The green alpha, enter, and it solves for it right there. Look at that, folks. 193 and 33 cents when we round to the nearest cent. Right there it is. It's the same thing if you want to use that mode. Okay, so the monthly payment is $193.33. We have the monthly payment. Woo! Take a deep breath. Okay, now we're going to find out, take the monthly payment, we're going to find out how much in total does the person have to pay on this loan. So we know that there's 60 payments to make. We know we're paying $193.33 per month. Well, then $193.33 times 60 gives us how much the total is this person is paying on their loan. They're going to end up paying $11,599.80. Remember, the loan was $10,000, right? So they're going to pay more than $10,000. Well, what is that more? That more is your finance charge. That more is your interest. So to find that interest, we're going to subtract. We're going to take how much you paid minus how much you borrowed. That's going to give us a number like $1,599.80. Well, that's the interest. That's the finance charge. This person who took out this loan is going to end up paying $1,599.80 as the final interest on that loan. All right, that's the setup. Here's the practice. You can do this one however you want. You can use the monthly payment formula. I'll give you some time. Give this one a shot. It's Hannah is taking out a 4.3% loan to purchase an $18,000 car. The length of the loan is 8 years. How much will she pay in interest? You can use the monthly payment formula. You can use this link here to an internet monthly payment formula calculator, or you can use that great little financial app on your calculator. However you want to do it. Let me give you a minute to give this a shot.
Wait, so we have the principal, which is the the 18,000.
18,000 is the principal, right? So I'm gonna do the top first. I'm gonna do the Mr. Salt way, the top
Gotcha.
first. So I'm gonna do 18,000. That's my principal
Parentheses.
times
Yep. Your APR.
my APR. So I'm gonna convert it to a decimal in my head.
Yep.
If I didn't know how to do that, I'd have to take this 4.3 and divide it by 100, right? Which I can do in my head by moving this decimal place
Times.
over. Yeah, not times.
Divided by your 12.
I got divided by the 12 first. Yep. New
Times
parentheses.
1 plus
I can put a new parentheses, 1 plus. Yep.
your APR.
APR point oh, what was it? 0.043 divided by 12 again. R divided by 12. Closing that parentheses out.
12 to 24. I mean to the 12th. Yeah.
Yep.
Right.
I got to raise it to 12 times t. What's 12 times t in this case?
Who knows?
Okay, well, fortunately, the calculator will figure that out for me. If I press the caret button, notice how it goes up here. So when I want to show that off again, I got to go to that caret button. Caret brings me up here to the exponent. I can just do 12 times t is 8. T is 8. It's 8 years. So I can just do 12 times 8. And then I can press enter at this point, and it will solve for the top. It will solve for the top of my, I did something wrong. Let me go back. This can happen. Don't be, okay, so I'm going to go back. I'm going to press enter. I didn't put an exponent up in here. It wanted a new exponent. So I'm going to put 1 in there because 1 doesn't change anything. Now, okay, so now I have the top. I have 90,000. So the bottom, I'm going to use parentheses. 1 plus, right? The rate, which is 0.043, yes. And I got to divide that by 12. Dividing that by 12. Closing my parentheses, just like it is in the formula. Raise the power of. Again, that's 12 times t. T is 8, right? 8 years.
Yep.
And then I have to press that right button. That's important. Pressing that right button to bring it back down. -1. All right, this is the bottom of the denominator. There's my denominator. So now to solve this problem with the monthly payment formula, I go back to my numerator. I press enter, pop that in there. Divided by, go back to my denominator, put that in there, and I press enter to solve. And whoo, I got this $221.93 when I round to the nearest cent, right? That's the monthly payment, but that's not the interest. That's not the interest. That's just the monthly payment, what I have here. So I did all that work, and all I have so far to show for it is a monthly payment. So here I go. Now I gotta figure out how much the total is. Right? Remember, I had to go back over here. I had to find the total of how much is paid. So monthly payments right here. I got to multiply it by how many monthly payments I made, right? So how am I going to do that?
So you multiply 8 times 96.
Ooh, so 8 I like because it's 8 years. But now I need a number that gives me per month. How many months are there in a year?
12.
There are 12. So I got to multiply it by 8 times 12, right?
Yeah, that's 96.
Oh, okay. I got 21,305.
Wait. 8 times 12.
8. Oh, yeah, 8 times 12 is, I see what you mean. You're saying that 8 times 12 is 96.
Yeah.
Correct, sir. So I could have absolutely gone up here and taken my monthly payment and multiplied it by 96 right off the bat and gotten the same.
That's what I was.
Okay, there we go. Then we're on this. We're totally on the same page there. Yep, we're on. See the same number. Doesn't matter. So if you can do 8 times 12 in your head and you know that's 96, good on you. If you don't know that off the top of your head, you just do 8 times 12. The calculator will do that calculation for you. Okay, we have the total amount paid on this loan, but that's not the interest. What's the interest?
So you take that total amount minus the loan,
right?
You'll get finance charge.
Right. This amount is greater than the original loan. So this minus the original loan which was 18,000. That was my principal. Whoop, I made my calculator go away. Come back, calculator. No, come back. Minus 18,000. So my total paid minus the amount I borrowed is my interest. That's my finance charge. Woo, 5-minute warning. Okay. So this is the number that's going to go in here. This is the interest, rounding the nearest cent. Now, if you rounded earlier, you might get a slightly different number. This is like, we didn't do any rounding here until the very end. That's the that's the way the bankers will do it. But I'll usually accept one or the other. So, you can round to the nearest cent each time, but the bankers will not round to the nearest cent to the very last calculation.
C
they're
is a
looking
slope.
for.
I got this. It's not that hard.
Okay. So I'm going to let you guys take on David. All right. You guys take on David's situation. But before we leave for the end of the day here, I want to just do a quick little review on some properties of mathematics. All right. So I know you guys know these. What is this expression here? 2 times 2. What do we got?
4.
4. It's not a trick question, right? They're going to get slightly harder as we go, right?
Yeah.
What is 2 to the power of 2, though? What is 2 to the power of 2?
8.
Ooh, okay. You remember what 2 to the power of 2 means? What does 2 to the power of 2 mean?
2 times
Means
itself.
Yes, it means 2 times itself twice, right? So 2 times 2. 2 to the power of 2 is the same thing as 2 times 2,
Yeah.
which means we still got 4 again, right? Are we good?
Yep.
Yeah. 2 to the power of 2 is the same thing as 2 times 2 because it's 2 times, it's 2 times itself twice, which happens to be the same thing. All right. So now, what is the square root of 4?
2.
2, right? Because 2 times 2 is 4. 4, the square root of 4, it becomes 2, right? We undid with the square root what we did over here, right? 2 to the power of 2, the square equals 4. The square root of 4 gives us the 2 again that we started with. All right, so let's do this pattern. Okay, what is 2 times 2 times 2?
16.
Oh, you had it right the time before that.
Wait,
2 times 2
8?
is 2.
Wait,
It is 8, right? It is 8, yes.
Times 2. 2 times 2 is, oh, okay.
Yeah. So 2 times 2 is 4. 4 times 2 is 8. So we gotta pick 8 right there. I'm glad we're doing this little review. It's a little like we're trying to remember what these mean again. What is 2 to the power of 3? Woo! What is 2 to the power of 3?
6.
See, this is one of those common things, those common errors, right? So oftentimes people will say 2 to the power of 3, that's 6, because what they're doing in their head, they're saying 2 times 3 is 6. But this is 2 to the power of 3. So now it's going to be 2 times 2 times 2. It's 2 3 times. Just
So
like
2 is 4.
we
So that 4 times the 2 will be 8.
Exactly. So 2 to the power of 3 is actually 8 because 2 to the power of 3 is the same thing as 2 times 2 times 2. There's 3 2's. 2 to the power of 3 is 2 times itself 3 times. Okay. So we're stretching those brain muscles. All right. What is 2 cubed? What is 2 cubed? It's the same, right? It's 2 to the third power. It's 2 times 2 times 2. That's 8 again. Okay. Sorry, I'm doing these just because I know you guys probably have seen these, but you probably don't work with these on a lot. So I just wanted this little review. We're almost near time, right? What is the cube root of 8 then? What is the cube root of 8?
4.
So you might be tempted to say, well, 4 is half of 8, so maybe it's the square root. Not quite, but so the cube root is what number times itself 3 times? Cube root is the third power. What number times itself 3 times gives me 8? Well, 8, no, see now 8 times 8 times 8 would be 8 cubed. What's the cube root of 8? The cube root. It's like square root. It's 2 actually, right? Yeah, Mr. K says I'm a tricky man. So the cube root of 8 is 2 because 2 times 2 times 2 is 8, right? So if 2 cubed is 8, then the cube root of 8 has got to be 2 again, right? We get back what we put out. Okay. What is 3 times 3? All right. That's hopefully we know that. 9. That's pretty easy. 3 to the power of 2. 3 to the power of 2 is the same thing as 3 times 3. That's 9. All right. So what is the square root of 9? What number times itself gives us 9?
2?
No, because so I said 3 to the power of 2 is 9, right? 3 times 3 is 9. So the square root of 9 has got to be 3, right? The square root of 9 is going to be 3 because the square root's asking you what number times itself is going to give me 9, right? What number?
It's tricky because
they are tricky, and I'm so glad because at first I was like, oh, Desmond's on this. He knows these, but like
Yeah,
I can tell you know these. I can tell you know these, but I can tell you're rusty. I can tell you haven't used these in a while. So this is good. We're doing this review. All right, so here we go. I'm going to get tricky here. I'm going to get tricky here.
Both saying it right.
3 times 3 times 3? What's 3 times 3 times 3?
9, 18.
Ooh, closer.
3 times 3, which is 9 times the another 3.
9 times 3 is,
Wait, 20? Is it 27?
it's
Yes.
27. Yes. 20. So we got, so 3 times 3 times 3 is 27, because it's 9 times 3 is 27. What is 3 cubed? Not trying to be tricky here, right? 3 cubed is the same thing as 3 times 3 times 3, which is,
Can I say something?
yes.
All right, so and it dawned on me because saying it so many times, and it really is reaffirming when you hear it. If you hear the cube root, that means you're going backwards.
Yeah, you're going backwards. Yep.
So if you go root, you want to get smaller, so it's like the root of the problem. If you want to say
Yeah.
cubed, it's getting larger. It's like tripling.
Yeah.
When you slow it down and you think about it, that's why my son's getting up. Okay. I'm done talking. Sorry.
Okay.
Like it's like
So-
I knew these, but 10th grade that they gave me geometry, and then that just messed me up.
Yeah. Yeah. So I have I don't know how many more of these I have, but I'll just talk about them. So the cube root of 27, the cube root of 27 is actually 3, right? Because we're undoing the 3 times 3 times 3. The cube root of 27 is 3, because 3 to the third power, or 3 cubed, it's going to be 27, right? 3 to the power of 3 is going to be 27, right? Because it's 3 times 3 times 3. 4 times 4 times 4, right? So 4 cubed, 4 cubed, well, 4 times 4 is 16. 16 times 4 is 64, right? So that'd be 64. What is 4 to the power of 3? That's the same thing as 4 times 4 times 4. It's 4 3 times, multiplied by itself 3 times. That's 64 again. I'm not trying to be sneaky. I'm just trying to get you to understand the relationships here. What's the cube root then of 64? Well, it's got to be 4, right? Because 4 is the number. Oh, sorry. Actually, I'm sorry. I take it back. I was being tricky here. The square root of 64 would be what number times itself?
8.
It'd be 8, right? Because 8 times 8 is 64. So I need to read a little closer. I'm probably gonna, and I didn't ask about cube root of 64, but the cube root of 64 would be 4, right? Because it's 4 times 4 times 4. Okay. So finish David up, submit this, and we're done for the day. All right. I went 2 minutes over. Apologize for that. All right, just finish David's problem up, back up the top, and you're done for the day. Thank you all. Apologize for going over. I try to stick fairly close on time. Any questions? I'll take questions.
Have a good day, everybody.
Thank you, sir. You have a good day.
You too, Desmond.